Okay, good afternoon. It's already afternoon. So let's just continue for our video support for physics topics dynamics. So problem 29, a 45 kilogram crate of tools rests on a horizontal floor. You exert a gradually increasing horizontal push. So that is a varying force on it, and observe that the crate just begins to move when your force exceeds 330 newtons. After that, you must reduce your push to 208 newton. So, after you exceeded the 313, hihinayon mo lahiya kaysa 313 to 208 by moving it at a steady 25 meters per second squared. So take note of that word steady. So again, that talks about constant velocity. So you could just imagine if you still use the 330 Newton force, that would create an acceleration. That would be Newton's second law. So this one is under Newton's first law. Static, and then this one is for your Newton's first law because steady gihapon hiya. Okay? So, may I draw first the problem? A 45 kilogram crate. Crate, I think it looks like this. Diba? Like a basket crate. Then you have somewhat here. So, it's a crate. Let me one. Then, you push it. So, this is me. Maybe you don't want to be drawn. How I draw it. With a constant push. So the problem says the mass of this crate. So again, I'm not a civil engineer. I'm a chemical engineer. Therefore, it's bearable for me to draw like that because I wasn't accepted as a civil engineer aspiring during my time. 45 kilograms. So the mass is 45 kilogram. Then next, 45 kilogram crate tools. So there is. Anyway, you have maybe I can just imagine my saw here. What's that? That's a saw. Then maybe you have a martillo. Yan, that's it. I can somewhat draw. But anyway, that is a crate for tools. Then you have, you push it. Of course, there is a friction for that. Your friction again is a force that is always counter the movement. So it always counters the movement. Okay. So if you push it that way, your frictional force would be this way. So this is your F. Then you have of course your normal force in this. We call it N. And then you have also your weight at the crate, which is that mass multiplied by the force due to gravity, the pull of gravity, which is the acceleration due to the pull of gravity, which is Wmg. So there is that F. Control C. So this F is actually what this man is doing, pushing that crate of tools. Again, then the question is, what is that muse S and muse of um, K? So I think there would be um, I think there would be two equations to unknowns for this. So we can use by calc. So anyway, we'll set up our equation. Of course, this is first law, so you have to have a summation. On x, you have first law equilibrium. Summations of force on x is equal to 0. Again, at rest, before it moves. So positive is going to the right, your F. And then negative is F. So there are two forces for your x, and for your summations of forces on y. Summations of forces on y is equal to 0. There would be how much? uh, you have your going up is normal force, while going down is W. Okay, or equal to mg. Now your problem is about this F. So what is this F? No, the given is this F. This F is given, and your problem is μ of S and μ of kinetic. So the coefficient of static friction. So if this is before it moves, so this is static. So you're calculating frictional force as S. Okay? And that F of S will relate that normal force. F of S is mu static n. Of course, if you will make this as equal, it is the maximum. Okay? So that's what's that this equation tells you about this lesser than. So if we will make this as an equal as the use of static n, that would be the maximum frictional force before it slides. Maximum frictional force. And that's what it says with the problem. You start from 0, and then after you've got the 313, it starts to move. So that 313 is that maximum Fs, letting this equal, letting this sign to be an equal sign. Okay? So Fs would be the frictional force that will counter that F when your equality here, when your less than greater than is changed to an equality sign. So therefore, you would have an F from the summations of F's on X is equal to 0. You would have F minus F sub S. F is equal to F sub S, which is equal to mu S n, which is n now is related by summations of force on Y. Your W here, your W is equal to your normal force because there are only two forces that is going to the Y direction. So your N would be replaced by mu sub S. Your N would be W or mg. Um, W and your use S would be equal to mg. So basically, you don't have your mu s, so therefore you can calculate your mu sub s. So you can already calculate your mu sub s to be you substitute to be F all over mg, and that F is given, that is 330 Newton. So I will resolve it to uh, 313. So during N2 equations are known because it's already solvable. 313 Newton, I will chug it down to kilogram meters per second squared. That is your Newton. And then your mass, which is a 45 kilogram. And then your 9.80665 unit is meters per second squared. So you have mu sub s to be 313 313 divided by 45 times 9.80665. So that will give us up to 0.71 to two significant figures. I think two significant figures will do. 3, you have 3 significant figures. Maybe you can use 3 significant figures for this. You have 0.709. Muse of S is 0.709. So there's no unit for it. So that is your static. Now, in terms of movement, same equation applies, but only now your for letter, for the next one, your f of k is equal to your um, muse of kn. Okay? And it's already equal, while this one is lower in value. Usually, the muse of k is lesser than muse of s, because you really have to have bigger force. Ang matanasan kita nga mas masayon, mas makuri pagduso kung diri pa na andar. Pero kung once umandar na hiya, mapapansin natin mas madali na talaga pagduso. It's because of this. Your mu k really is smaller than your mu s. So you have already a idea that mu k should be smaller than this. Anyway, same equation applies. Your F, diretso na still be the same. Same summations of forces. Your F is equal to mu k mg. And then your mu k would be equal to, of course, that is smaller force that you need. That is a 208 Newton. That is a 208 Newton. That is kilogram meters per second squared all over your mass, which is 45 kilogram, and then your uh, acceleration due to gravity 9.80665 meters per second squared, and that will give us 208. So that will give us 0.471. So that is 0.471 for the mu k. Okay? So after, where are the coefficient static and kinetic friction? So that is for your letter A. There are two that is being asked, static and kinetic. Okay? I'll just continue so that it would not be too long. Thank you guys for listening. Okay, we'll continue with problem 29. Letter B states that what push must you exert to give it an acceleration of 1.10 meters per second squared? C. So there is letter B. What push to give it an acceleration of 1.10? Is the problem from rest or from to give it an acceleration? To keep it moving at 25 meters per second. What push? Okay. So push, that will give you an acceleration. Anyway, from our we only have to change this one. Okay. So maybe we can erase first. The same is um, the same is what? The same is the problem, but it would be the kinetic. So we would be using this 4.471, 0.4713 actually, 208. Where did I get this 208 kilograms? It's given from the problem. 208. Okay. So that is 0.471. So I'll delete that, and then I'll use the muse of k, that is the coefficient of friction. Mu k is 0.471, and then we'll calculate that f, that will give us an acceleration of 1.10 meters per second square. Did I get it right? what push. So F, an acceleration of 1.10 meters per second squared. So we go back to our second law of Newton's second law. That is instead that the summations of forces on x, because that's where the acceleration is, the direction of your acceleration. So it must be on x. Summations of forces on x is equal to ma. Okay, and of course that mass is talking about the mass of the crate steel, and then this is given as a 1.10. So this is a 1.10. So the question is what push. So you can go back to your summations of forces on x, so which is equal to ma, and you have an F going to the right, and you have your minus frictional force going to the left. Okay, so that F is equal to F plus ma. Okay, and that F is again related to the normal force, which is Fan. Use of kinetic because it's moving multiplied by N. So this is the F, and then ma, ma, the acceleration, which is 1.10. Now you still don't have an N, you go back to the summations of force on Y, which is 0. So again you have a second law on your X while a first law on your Y, because you don't have any movement on your Y. So that must be in equilibrium. So summations of Fy means that your W going down negative plus your normal force going up is equal to 0, and then your, of course, your weight and your normal force is the action reaction pair. So you have a normal force here, so this would be mu k, and then you would have W plus mg or ma, and then mu k is mg plus ma. You have the same m, you have mu k multiplied by g plus a, acceleration. So we can substitute. Mass is 45 kilogram. Then you have mu k, which is 0.471, and then you have 9.8 0665 meters per second squared, and then plus you have your 1.10 meters per second squared. So you have meters per second squared as a unit of the two for addition, then you have kilogram here. So you would have a Newton for 57 Newton. So the answer would be a 257 Newton. Suppose you are performing an experiment on this crate, but we're doing it in the moon instead. Restoration to gravity 1.62. So actually, you will just replace the gravity 1.62. If this is still the same material, meaning the kinetic friction, the coefficient of frictions, the muse s and the muse k would still be the same. So that is, you have a muse, let's just write it, kinetic is 0.471. How about the muse of s? We'll go back to our videos. I think that is I think this is the one. Okay, good. You can use by calc. So anyway, we'll set up letting this 80665 while this one is 0.7 lower in value. Usually, okay, that it would be 0.709. Muse of s muse of s is 0.709. So we will be using that one. So suppose we're on the moon, then we will have letter CI, this is letter CI. Problem CI, C, and then you have I. What magnitude of push? So that magnitude of push, that would still be same here, but of course the first one, as we solve the first problem, that would be your force is equal to your frictional force. No ma, because summation of forces on x is equal to 0. But of course, your force would be on ma, and then F still the same, since you would still have the same setup. Your F is muse of Sn, then N is equal to mg or Wmg. Okay, mg. So muse of S, that is 0.709, and then you have your 45 kilogram, and then multiplied by 1.62, your acceleration due to gravity of the moon. So you would have that frictional force, frictional for that push to counter that friction. So this would be smaller talaga. You can expect that this should be smaller because the gravity pull is small. So that should give us a 51.7 Newton for the push. And then for letter CII, so I think we are asked to find the acceleration due to gravity. What would its acceleration be if you maintain the push? So if you maintain that push, so your summations of forces on x will now make an acceleration. But that summations of force on x is force minus F. So therefore your F is equal to F plus ma. Okay, same acceleration, but your F now is um, mu k n plus ma. Then your n is equal to W mu k W mg. So we could just go back up, go to mg, and then you have ma. And then you have the same mass, you can have mu k g plus your acceleration 1.10. This one is 1.62. Of course, this is the A, this is now the G. Okay, so as you still have the same 45 kilogram, then you would have your muse of K, which is 0.471. The G is 1.62 meters per second squared, while the acceleration is 1.10. Unit for this one is meters per second squared. So therefore, um, sorry, you're going to calculate for the acceleration. So this is wrong actually. So the same force you're going to apply, but you're going to find the acceleration. So we're going to use for the F257 here. Uh, Same push, sorry, 257 Newton, and then we can get the acceleration here. We can have MA is equal to 257 Newton minus mu k mg. Then acceleration would be equal to 257, I'll check it down to kilograms meters per second squared, minus muse of k, which is 0.471. The m actually is 45 kilogram, and the g due to the moon is 1.62 meters per second squared. So 45 kilograms. So you have an acceleration which is in meters per second squared. So that would be 257 minus zero point 0.4 times 0.471 times 45 times 1.62, and then you have a 45. So that will give us 4.95, acceleration of 4.95 meters per second squared. So this that is for CI and CII. Thank you guys for listening.